trees. So what is trees in data structure? Tree represents the nodes connected by edges. We will discuss binary tree or binary search tree specifically. So we have a sample program here. So in this part, this is what we call the tree node. Tree node, it has a data part and references to its left and right child nodes. So what is child node? Child node is the node given below a given node connected by its edge downward is called its child node. So what I used an insert operation here. So it inserts an element in a tree or create a tree. So this is the insert operation. So now we're going to tackle about heaps. So what is heap? Heap is a special case of balanced binary tree data structure where the root node key is compared with its children and arranged accordingly. So we have a sample heap program here. So heap implemented here is minimum heap. So first we're going to initialize the heap. Next, let's insert an element into the heap. Next, heap 1 is the minimum element. So we remove heap 1. So now heap 1 has to be filled. We put the last element in its place and see if it fits. So if it does not fit, take minimum element among both its children and replace its parent with it. So here, this is where we demonstrate the heap. So that's it for the heap. So next, we're going to tackle about what is graphs. A graph is an abstract data structure that is used to implement the mathematical concept of graphs. It is basically a collection of vertices, also called nodes, and edges that connect these vertices. So we have a sample graph program here. So first, we are going to define the maximum number of vertices in the graph. So this one, it is the data structure to store graph. Next, an array of pointers to node to represent adjacency list. And next is where a data structure to store adjacency list nodes of the graph. So next, it is the data structure to store graph edges. So this one, it is the function to create an adjacency list from specified edges. So this one, it is where we allocate memory for graph data structure. So next, it is where we initialize head pointer for all vertices. And this one, it is where we add to the directed graph one by one. So here, it is the function to print adjacency list representation of the graph. So here, lastly, it is where we are going to implement the directed graph in C.